Welcome back everyone, Mike McConville here again, Stratford, Ontario, Canada. And we've got a couple of black Strats with maple necks, basically the same job on both guitars. So we have this Squire Strat for Paul, and I'm just bringing you in so you can see where we are with this compensated nut. So this is what we've got right now. So I've thicknessed the leg and got a nice press fit. And let's have a look at the other one. So this black American Strat of Richards, same deal. You can see how much shallower that slot is than the Squire. Same idea, got the thickness of the leg so we get a good press fit, and we have done that first radius on our radius disc sander that fits in the drill press. I'm doing these two in tandem, so we'll just walk you through step by step. Okay, this is our next step. I've scribed that radius for the underside of the ledge, and we're going to cut that down. And that's what we got. Now we'll reduce the height of that leg that drops into the slot. Back to the guitar again to check this. I'm going to bring that down just a little bit more. Back to the guitar. Well, that new sander definitely fast-tracked this job. So that's the Squire nut blank done, ready for slotting. And this is Richard's American Strat. We're going to bring that to the same stage as that Squire. So the Fender style nut presents several different challenges that you don't come across with a Gibson nut. Mainly, the underside of the leg that goes into the slot is actually radius, just like the fingerboard is radius. And everybody knows the fingerboard radius on a Fender is much steeper than it is on a Gibson. So the leg that goes into the slot on the American Strat is much shallower than the leg on the Squire Strat. So both the Squire and the American Strat are ready to be slotted. So Paul's Squire Strat nut has been slotted. We're going to set that aside now and get on with the frets. Same thing with Richard's American Strat. It's been slotted, blank is press fit. We're going to remove it and get on with the fretwork. One of my subscribers had recently asked, don't you straighten the neck before you do the fretwork? And of course the answer is yes, of course I do. I didn't happen to mention it in that video though. But I'm going to mention it in this one, and definitely mentioned it in at least 100 videos. But here's what I've got. I kind of like this length, a 10-inch straight edge, because that tells me that this portion right here is a little bit proud. So we're going to back off the truss rod until I can lay that 10-inch straight edge on there without that jiggling. So just back that off. Let's try that again. And you know something? That's all it took. Thanks for asking that question, by the way. So the idea is to get the neck as straight as possible, and then I go over with a shorter straight edge and then check for any high spots. So the neck on this guitar is actually quite good. So there's one high spot right here. So it does not need a lot. I'm going to just breeze over that very lightly with a file. Of course, the other super important thing is the neck is supported along its length, so when you're pushing down on the file, the neck is not flexing. And even beyond that, the actual body is held firmly. So the body and the neck are both held simultaneously while I do this job to restrict any chance of deflection as I'm filing. So I'm just going to very lightly go over this. No, I haven't masked off the fingerboard yet, but I will. You can hear that file just sort of gliss along those frets, very little resistance. And another reason to take the nut out is we can go from the first fret and make our way up the full length of the fingerboard. And that should be it. So we'll check our 10-inch. The thing about the 10-inch, you can kind of divide the neck in thirds. So bottom third, kind of middle third, top third. And that's what I'm doing right now, just quickly going over with the long straight edge first, go back to the shorter edge where I can bridge 3 frets, and that's all good. Yeah, we got that one spot up here, and I am good with that. Now, it definitely needs to be masked off. You don't want that maple exposed when you're doing your recrowning and polishing. So I'll go ahead and mask this off now. Now I am using a lower tack painter's tape, so we don't pull any of that lacquer off. We are just getting ready for the final buff on Paul's Squire Strat. It's just that I bring you in for a close-up of the frets before I buff. If we go up the top, I don't know how much the camera is going to show, but we pretty well got rid of all the traces of string wear. I think this final buff is going to do it. You want to give this The compensated nut blank is done, nice press fit. The frets are leveled, crowned, polished, all ready to go. I pulled the pick guard up to put some longer springs in the bridge pickup. There wasn't enough K value in those springs to actually pull the pickup down away from the strings. It was just kind of flopping around in the cavity. So I took the whole Strat harness and pick guard off, and lo and behold, this is the pivot post on the base side of the bridge. So that is what we got to deal with. So that puts the brakes on for a bit on this job. Here we go. So this is the, oh God, this is what was in there. Well, you know something? We're not messing around with this. So that's what we got now. We'll put a solid maple 1-inch dowel in there. That's where we're going to start. Back to the tech deck. I have this drill press on the foot switch as well. I'm going to cut this just a little proud. And we'll flush this up. Again, I've got this one on a foot switch as well. Set it spinning and just let it idle to a stop. I'm going to try and get this dead flush level with the top. Okay, let's go take a look. Okay, this is 24-hour aviation epoxy. We're just going to butter that up. The nice thing about this is the actual dowel, the post will end up being in the center of the maple dowel. So we're not really depending on any type of a wood joint to withstand the pressure. Really try to get like exactly the right amount on here. We really don't want to have to mess with any squeeze out. So I think we're good. I'm just buttering the one side because it's maple, right? So it's not going to absorb anything. It's like marble. Okay, let's get that baby in there. Oh yeah. Yeah. We'll come back tomorrow and we'll drill that out. So this is what we've got. We've completely filled that solid with a 1-inch maple dowel and then just flattened that one edge to conform with the cavity. Richard's bridge problems will be over forever. We'll let that set overnight. This is 24-hour epoxy, and then we'll come back and get the post in the right place and get on with the rest of this repair. Cheers. So I've determined the center to center distance, but before we drill out this dowel, there's a bunch of other reconnaissance that we need to do. I want to show you the original fastener and its dimension, and a potential Fender replacement fastener and its dimensions. So before we drill that hole in the maple dowel that I just installed, you need to understand a little bit more about these fasteners and how they work. So the hole that we drill needs to be countersunk. The cuff of this original fastener is 1/4 inch in diameter. The body of the threaded part of the fastener is only 1/75 thou. The outside diameter of the threads from here to here is 238 thou. Now I'm looking at stepping up to a larger fastener for several reasons. One being the threaded length of this Fender fastener is 1.049 inches as opposed to this length, which is 0.772 inches. This fastener is deep enough to actually go through the floor of the dowel that we just installed and tie that dowel into the rest of the body. So this is the depth of the body, which is 1 3/4 inches. So there's plenty of room for that longer fastener to go in there, and that is the route we're going. I'm going to cut this dowel in half just to show you the cross section. So the hole that's bored to receive this fastener, the top portion of that hole needs to be wider to allow for the wider cuff, which is 1/4 inch. And the hole that's drilled full depth needs to be at least as wide as the body of the fastener. So the outside diameter of the threads of the fastener are 2/38 thou. The actual body of the fastener in between the threads, that thickness is 1/75. So essentially what you're counting on is to drill a hole that allows the threads to cut into the maple, because that aggressive wood thread serves as the height adjustment for your bridge. So the diameter of the hole that you drill to receive this threaded portion needs to be a tight enough diameter for the threads to bite firmly into the maple walls of the hole, but not so tight that you split the dowel. So this is what you need to be careful with. So I'm purposely leaving this chart on freeze frame so you can look and verify these dimensions, or stop the video and have a good look at the dimensions of these two different fasteners, the replacement fastener and the original one that came out of the guitar. Now both of the original fasteners, a little bit of a bend in this one, so I'm definitely going with brand new replacements. So this is the Fender part number for the chrome pivot pin that we have here and the one that we're using, but if you did want gold, it would be the same number with 200 on the end, and if you want black, it would be 300. I've located the center for the hole for this replacement post, base side post. I always like to start it with these micro bits by hand. Obviously I'll drill this hole on the drill press, but we're going to get it started to get that center by hand first. There we go. So this close-up shows you how the threads of this fastener bite into the maple wall, and the actual cuff you need to countersink to allow enough room for that cuff to kind of move up and down. That's biting in almost too much. I just want to make sure that we don't split that dowel, so I'll probably reduce that a little bit from what it was. I'll just give you some numbers on this. So the drill bit that I used to through drill was 194 thou. So that represents the diameter of this hole. If you take that diameter of 194 and you subtract it from 236, that'll give you 42 thou. So that means you've got 42 thou biting into the wall of the maple dowel. Now I actually found that a little bit too tight, so I'm going to go with a slightly larger bit than this one, that 194. So I'm doing all my experiments with a maple dowel long before I drill those final holes in the body to accept those new fasteners. So I stepped that diameter up to 206 thou. So our outside diameter on the threads was 236 thou, so that gives us 30 thou of bite into that maple wall, and that feels really good. I scraped a little bit of paraffin wax onto the threads, and I'll show you when I do the install on the guitar, and that moves up and down freely, good and tight, without any danger of splitting anything. So that's what we're going to go with. 206 thou drill bit to drill for those 236 outside diameter threads, and that cuts into the maple perfectly. So I'll drill out this original hole first for the deeper depth of the replacement fastener. So now we're cutting the countersink for that cuff so that it moves up and down like a piston. A little bit of a different approach on this one. I'm going to use the brad point bit first because I've got our center marked. So I'll drill this one first. And now we'll drill the deeper hole to take the wood threads of that fastener. I need to point out that the orientation of the wood grain, it goes from here to here. So because we have that aviation epoxy sealed on either side of the hole that we drilled to take that fastener, the chances of anything cracking from the force of the strings pulling this way have been greatly reduced because this surface here is adhered with that 24-hour cure aviation epoxy. Same with this. It greatly reduces the risk of this cracking again like it was earlier. So I just wanted to point that out. Grain orientation, very important. This is not arbitrary. I turned the dowel to make sure we had the grain orientation going in this direction. So if we turn the dowel like this so the grain was going in this direction, there'd be a much greater chance of that breaking. Because we've turned it like we have a break stop on either side of that grain. For the little bit of dowel that's actually exposed, because this is end grain, even maple absorbs on the end grain. So just color that black. For the tiny little bit that is exposed, nobody would ever notice in 100 years. So the structural integrity is 100% restored. Actually, it's a little bit stronger than it was when it left the factory with those deeper fasteners. So we'll just drop this in. So the vertical movement of this fastener is now just as smooth as a metal machine thread. No problem at all. We've got all the adjustment in the world, smooth as silk. Let's drop those pickups back in. Now we're back in business. Just hooked up those ground wires, and it's just a matter of hooking up the input jack now. So this one, the pick guard kind of slips underneath that. Okay, I think we're good to go. I have a couple of hockey pucks stacked in between the rails of the body platform to hold the bridge in place while I've got it face down. Now this claw was cranked right to the max. He definitely wants to be able to dive with this thing. So this is being set up to dive only. It's 10 to 46 concert pitch. Okay. That's how I stack those hockey pucks underneath to hold the bridge in while we kind of set it in place. And now, of course, we've got all kinds of adjustment. This turns silky smooth. All right, let's tune it up. Well, both of the black Strats are done. So we'll bring both of them into the house, plug them in, and let you hear them in a minute. But before we do that, this is Paul's Squire Strat. I know there's been lots of different configurations of this way to sort of turn the tremolo Strat into a hardtail. Now that was the chunk of wood that was in there, and I think it was just through sheer frustration he couldn't tune the thing, and that's why he ended up bringing it to my door. He did create a bit of a scar there, but at least it's going to be underneath the plate. I just wanted to show you my take on this. So this is set up to dive only. And I know that Paul said he never uses the bar, and I get it, and I'm okay with that. So what I've got here is I've got a piece, nothing's glued, and the guitar is not altered in any way, shape, or form. So this piece of basswood basically fills that void and turns it into a hardtail guitar. But if at any time in the future, Paul, you decide you want to try the tremolo, well, you know something? You can just slip this thing out, and it's good to go exactly as it is. Don't touch a thing. So it works perfectly fine for dive only. We've got 4 springs in there, 10 to 46 concert pitch. But in the meantime, we're going to go hardtail, but it's completely reversible at any time. If at any time in the future, Paul, you decide to try the tremolo system, well, you can go right ahead and do that. You just pull this plate off and pull that basswood piece out, and your trem system will work just fine. And that is it. Both black Strats are done.